Students, welcome to my YouTube channels. Today again I am going to discuss the MCQ questions trick for the uniformly distributing load for the simply supported beam. So how the questions will come and how we'll answer, that trick only I am going to give here. So what is the question? A simply supported beam of span L. So AB is a simply supported beam. So that means this is the RA and RB will be the simply supported beam. So RA RB the support reaction beam and carries a UDL of the over a whole span. So throughout the beam, UDL is there, uniformly distributing load. Then they're asking what is the shear force diagram nature, what is the bending moment diagram nature, then what is the shear force at the center, what is the shear force at the supported end, what is the bending moment at the supported end, what is the bending moment at the center. Lot of questions they will ask. So only if we'll solve this shear force and bending moment diagram, a small 2 minutes time it will take. So you can answer all the multiple choice question. So first what we'll do, we'll solve all those things. That means shear force and bending moment diagram and support reactions we'll find. Then one by one answers we'll check here. So what is the support reactions here, how we'll find? So already we know two equilibrium equations, sigma f equal to 0 na total upward force RA plus RB is equal to total downward force na UDL. So W into L. So just write WL. So W into L. This is the equation 1. Give equations 1 here. Now moment about A we are taking 0. Moment about A 0. So total clockwise is equal to total anti-clockwise. So this is coming clockwise. UDL will come clockwise. So what is the UDL? W into L is the W into L the load, and moment means half distance we have to taking, equal to RB into L. Okay, so listen here. Taking moment about a UDL clockwise directions na W into L this load and half distance L by 2. So RB is equal to, here we will get WL by 2. So RB you will get here WL by 2. Then if you substitute here WL minus WL by 2, so RA also will come WL by 2 will come. So support reactions I know now. It will come WL by 2. So right here WL by 2, here also WL by 2. We got the support reactions. Now we'll see the shear force calculation. So shear force diagram calculations, how we'll calculate. So draw the first one zero shear force line. I draw the zero shear force line. Okay. So now what is the shear force at A? Shear force at A. So sign conventions already we discussed a lot of times. So this is a section. If downward force, right side, left side, upward force will be the positive and reverse will be the negative. Reverse will be the negative. Reverse will be the negative. So left side I am taking here. Left side SA will be the WL by 2. So here will be the WL by 2. Right outside space not there. WL by 2. So SA is equal to WL by 2. Then SB. Shear force at B. So total is WL by 2 minus SB, no? So this WL by 2, then this one minus WL. WL by 2 minus WL. So SB we can calculate here WL. So it will come minus WL by 2. Now we'll draw the diagram. So shear force diagram, if point load will be there, horizontal line. If UDL will be there, inclined line. So minus WL by 2 plus WL by 2. So we draw this. This is the center point will come. So take that point is E. So this is WL by 2 negative. This WL by 2 is the positive. This is the shear force diagram scheme. So now one objective questions will check here. A simply supported beam of span L, length L, carries a UDL over a whole span. Then what is the shear force diagram? Shear force diagram is a rectangle? No. Is a triangle? No. Two equal and opposite rectangle? No. Two equal and opposite triangle. Two equal and opposite triangle. This is the answer for that. two equal and opposite triangle. Why equal and opposite? This is the minus, this is the plus coming. So two equal and opposite rectangle. So this is the answer here. Two equal and opposite rectangle. One answer came. Now, then here you see shear force at the center. If the shear force at the center will be 0. What is the answer here? Shear force at center will be 0. If they will give same objective, a simply supported beam of span L carries a UDL over a whole span length. What is the shear force at the center? They will give choice 0, maximum, minimum, negative, positive, whatever. So answer will be 0. Answer will be 0. Shear force at the middle will be 0. Now bending moment we'll see here. Bending moment calculation, diagram calculation. So first MA will be 0 and MB will be 0. So we'll see the center, shear force at the center. Because one shear force will be 0, bending moment will be maximum. So here ME will calculate. ME will calculate now. What will be there here? WL by 2. Here sign conventions, how we'll take? See here, this is section. If will this clockwise, negative, anti-clockwise, this is right side, this is left side. Then opposite will be, this is clockwise, this is anti-clockwise, this is anti-clockwise, this is clockwise. So this will be the positive. This will be the positive. This is the center. So once you are taking moment OT, so this side is going now clockwise, RA going clockwise, positive. Then here in this middle point, we are taking E. This is point E coming. So this clockwise, WL by 2, clockwise, positive. Now this UDL will be negative. What is the UDL? First load will convert. This is W into half distance. What is the half distance here? L by 2. Half distance will be L by 2. So W into L by 2, this is the load. Then half distance. Half distance is equal to nothing but L by 4. Because UDL, now we are taking UDL. This is the distance L by 2. So W into L by 2 load and half distance L by 4. If we will solve here, what is coming here? WL by 2 minus, oh, this is here wrong. Just wait. Bending moment at E. So what is this? WL by 2. WL by 2 into length, because moment we are taking now into L by 2. So this distance I not taken before. So once we will take the moment about E, force into perpendicular distance. So WL by 2, this is force and length is L by 2. So what is coming? WL square by 4 minus WL square by 8. WL square by 8. If you calculate this, 8 not 2, 4. So WL square by 8 will come. WL square by 8 will come. So what is bending moment is coming? WL square by 8. So we'll draw the diagram here. So draw the zero bending moment diagram. Now what I told, if point load will be there, shear force diagram will be horizontal line. UDL will be there, shear force line will be inclined line. But UDL will be parabola. UDL will be the parabola. So UDL will be the this bending moment at B will be 0, at A will be 0. Here bending moment will be maximum WL square by 8. This is the point. Now look here. What is the question they're asking, right? Nicely. WL square by 8. Now the questions ask, if a simply supported beam of span L carries a UDL over a whole span, the bending moment diagram will be, come the choice here, bending moment. What choice they will give? Two equal and opposite, no, this is the other choice here. Parabola with maximum ordinate. Parabola with maximum ordinate at the center of the beam. Ordinate means this vertical height. X height is ordinate. The Y, this is the ordinate. This is the abscissa. This is called abscissa. This is called ordinate. So they are asking ordinate at the center of the beam. So parabola with the maximum ordinate. Maximum ordinate what is? WL square by 2. So this is the correct answer for this. Second answer, what is second? Either parabola with maximum ordinate at the one end of the beam. So maximum ordinate one end of the beam, both end is 0. So this answer is wrong. Triangle with the maximum ordinate, triangle will not come because UDL ke parabola will come. So triangle will come only for point load. So that way this is wrong. Triangle with the maximum ordinate at the one end of the beam, this also wrong because triangle will not form for the UDL. For the bending moment will be parabola only. So this way the answer. Now shear force at the supported end. Shear force at the supported end, what is? Plus minus WL by 2. See this answer. Same objective question they will give. They will give 3-4 choice. So what is the answer will come here? A simply supported beam of span L carries a UDL over a whole span. The shear force at the supported end will be, this is the supported end. This is known as supported end. So shear force will be plus and minus. So plus minus WL by 2. Now bending moment at the supported end. Bending moment at the supported end. That means bending moment at A, bending moment B equal to 0. This is the answer. See this. How many questions is coming for the one diagram. Now what is bending moment at the center? Bending moment at the center is equal to nothing but WL square by 8. 1, 2, 3, 4, 5, 6 objective. A lot of objective will coming here. So they will ask what is the bending moment at the center will be WL square by 8. What is the shear force diagram? Triangle. What is two equal and opposite triangle. So this way, if you know the shear force, this see already lot of questions we did this. So how to remember? Like this question, if you want to answer, if they are given simply supported beam, just to go through this basic. This is the basic concept. Based on this also, lot of questions also you can solve. So this is the basic trick to check the or to answer the all the objective questions for the shear force and bending moment diagram. So see this 1, 2, 3, 4, 5, 6 question is answer is here. Okay. Okay, students, watch the video, share this video to the all your friends so they can learn this how to solve the MCQ questions. Okay. Okay, students, thank you.